Industrial decarbonization faces cost and infrastructure reality. Industrial decarbonization is no longer in the phase of aspiration, it is in the phase of execution. For a while, everyone was focused on setting targets and drawing roadmaps. Everyone was talking publicly about how committed they were to reducing emissions. That was all well and good because it got net zero into mainstream corporate thinking. Ambition is all well and good. Execution is what gets things done. And execution is where the next phase of industrial decarbonization will be won or lost. The scale of the challenge leaves no room for superficial thinking. According to the International Energy Agency, industry accounted for 37% of global final energy use in 2022 and was directly responsible for 9.0 gigatons of CO2 equivalent emissions last year, or 1/4 of global energy sector emissions. Industrial decarbonization is not a side issue in net zero. It is one of the key conditions for its deliverability at all. This is also why, given current energy prices, the question of competitiveness has become inextricably linked to industrial decarbonization. This is why policymakers are increasingly acknowledging the point. For example, in Europe, the Clean Industrial Deal includes the development of an industrial decarbonization bank, which will be backed with up to 100 billion euros in funding. The important aspect of the sum is not just its value, however. It also indicates that the question of industrial decarbonization can no longer be considered solely in environmental terms, but also in economic and industrial terms. The discussion on industrial decarbonization has, in the past, been based on the assumption that technological development would automatically lead to implementation. This has always been an unrealistic assumption, however. This is because, even if the technology is commercially viable, it may still not be feasible, and vice versa. This is why the next challenge facing industrial decarbonization will not be the development of the technology, but its implementation. Steel makes this argument quite clearly. The World Steel Association reports that global steel production was 1,886 million tons in 2024, with an average emission rate of 2.18 tons of CO2e per ton of steel produced. This is enough to illustrate why steel is at the core of any attempt to seriously discuss decarbonizing the industry. No industry this large can be changed with slogans and pilot projects. It requires changes to the electricity supply, scrap steel systems, hydrogen supply, reinvestment in steel plants, and long-term planning. Cement is just as hard to change. The IEA reports that around 90% of the thermal energy supply to the cement industry still comes from fossil fuels, and that emissions intensity reductions of around 4% per year are needed to put the cement industry on a path to net zero by 2030. This is an extremely challenging rate of change in an industry where emissions come not only from fuels, but also from the production process itself. It also shows that industrial decarbonization is not just about fuels. For many industries, it is about changing processes that have been tuned over decades for cost and reliability. The first of these is cost. The technologies necessary for a high level of industrial decarbonization are technically feasible but not commercially viable. Electrification of heat, hydrogen, carbon capture, diverse feedstocks, and process redesign are all expensive technologies, and none are guaranteed to deliver returns. The issue is not that companies are not aware of the direction of travel. The issue is that boards are being asked to invest in a future that may depend on policy stability, the availability of clean power, and premiums for low-carbon products. A good example is hydrogen. It plays a critical role in difficult-to-abate sectors, particularly where direct electrification is not feasible. However, it is not economical. According to ARENA, green hydrogen in Europe currently has an average levelized cost of between USD 4.5 and 6 per kg. This does not mean hydrogen is not relevant. It means that hydrogen is not currently treated as a standard input in most industries. For most industries, hydrogen is currently a prospective input that depends on infrastructure development, cost reductions, and policy support. The second barrier is infrastructure, and this is often the deeper barrier. Electrification requires grid connection times and capacities, which many industries do not yet have. Hydrogen requires production, transport, and storage systems, which are still in their infancy. Carbon capture requires transport and storage systems, which are still far from ubiquitous. The actual barrier, however, is not just about choosing the correct technology. It is about whether the enabling infrastructure arrives in time and in sufficient quantities. The IEA has been clear in asserting that there needs to be faster deployment of near zero emission production processes, such as hydrogen and carbon capture, to help industries meet their net zero targets. This challenge is currently facing headwinds due to the overall strain on power systems. According to the IEA, global demand for electricity rose by 4.3% in 2024. The industry accounted for nearly 40% of the overall demand. This is relevant because many decarbonization pathways rely on electrification. Industry is being asked to use more of it at the same time that overall power systems face rising demand for electricity in transport, cooling, buildings, and digital technologies. Industry is facing not only incumbency in fossil fuels, but is also competing for capacity and flexibility in what is becoming a more crowded electricity system. This is why a stronger decision framework is now required to guide industrial decarbonization. Nor will the most promising strategies necessarily be those that promise the most. Rather, they will be those that are sequenced correctly. Energy efficiency should lead the way, as it can reduce emissions, lower costs, and increase resilience. Process integration, waste heat recovery, sophisticated control strategies, and digital optimization are not as exciting as hydrogen or carbon capture, but they are also likely to be more investable in the short term. Selective electrification should then follow, where conditions and logic dictate. Technologies like hydrogen and carbon capture should then be implemented where conditions are right, not where they are hoped to be right. The key issue is simple. Net zero in the industry will not fail due to a lack of understanding of climate targets among executives. It will fail if the risk of delivery is underestimated. Industrial decarbonization must now be judged not only by ambition, but also by robustness under actual cost constraints, variable infrastructure, and persistent market ambiguity. The easier phase is over. The harder phase is about delivering net zero under constraints that are actual, quantifiable, and ultimately critical. Dr. Farouk Sher is a researcher in energy systems, industrial decarbonization, and net zero engineering. His work focuses on clean energy technologies, artificial intelligence, energy transition, digital transformation, and sustainable industrial systems. He is also editor of the book Net Zero: Foundations, Technologies, and Strategic Innovation, and writes on practical pathways for global energy transition.